Cool. So I'm going to give you a problem to work out, okay? Have you passed the calculator quiz too?
Yes.
Awesome. This is a problem I want you to work on. 6 1/3 plus. Go for that. And I want you to talk everything out as you're doing it.
Probably I'm trying to turn 6 1/3 into a improper fraction.
Great.
So I'm going to need get the numbers, the denominator is the same. So we multiply this side by 4, and this side by 3.
Okay. Ready to show you my number.
Good.
If you want.
Keep talking.
Then we
There's an undo button at the top if you need to undo something. You see that blue thing up at the very top left?
yeah.
The blue one that's kind of back, up to the right, some up to the right, one more. Right there. Hit that once and it'll undo whatever you did.
76 over 4. Plus
3 times 3. It's okay, just scoot somewhere else. Can you simplify that?
Yeah.
How many times does 12 go into 85? Does it go in evenly?
No.
No, so what you're going to do is just turn it back into what? A mixed number. Okay, let's stop there. So now what I want you both to do, pull out a piece of paper and a pencil like you got. The problem I want y'all to think about here, we're going to talk about functions. Let's say that I give you this problem right here, guys. Here's our problem that we're going to work on. Got our x and y values. X and y. Cool. The values I want to give you are 0, 3, 3, 3. One, 2, 4. Guys, I want you to graph this and tell me if it's a function. What do you think, Ian? Why not? Doesn't pass the vertical line test. Why else, Ian?
Also because each x value has more than one, 3 is more than one.
Sure. So what he's saying here is, hey, I've at least got a 3 going to 2 and to a y. It doesn't work out. Because this 3 is the same as that 3, the same as that 3, right? Cool. So I would write down right now, test question. Oh, at the one that you just worked on. Highlight that, box it up, and write test question. You're going to have a test question that's similar to that one right there. What if I do this though? Now I'm going to give you, hey, let's say this, 0, 1, 2, 3, and now I give you the values 1, 3, 3, 3. I want you to write the domains and ranges for this. Give me the domains and range. You don't have to graph it. Just give me the domains and range. And then what I want you to do is tell me if it's a function. Wait. Let's go ahead and write them out first. Give me domain and range. How do you do domain and range?
Write out all the numbers. But if one of them we got.
Ian, what I want you to do is draw me. Wait, hold me constant. You got to write in small case. What you do is give me the domains. The domain. And Ian, after he's done, you can go ahead and write down the range. Cool. Perfect. Now, is this a function or not?
Yes.
Why is this a function?
Because each x value only one.
Each one only has one y, correct? Absolutely, that makes sense. So, yes, function, no function. Cool stuff. This table, I'm not sure that it's on the test. However, this concept right here of domain and range will be. So you might want to make a note of that. Concept of domain and range. How to write a domain and range is on the test. Okay. Give me a second here, boys. How much time do we have on the clock?
I don't know what it is.
I think it's around the 30-ish, right?
Yeah.
Okay, this is what I want y'all to do. It will tell you, actually, Peyton, if you look on that chart up to the left, look at C lunch. When does that end?
C.
Mm-hmm.
C lunch ends at 1:35.
35. Okay, so we got a little bit of time here. Huh? Oh, that's right. When does B lunch end?
B lunch ends at 12:30. 12:39.
12:39? Okay. So we got some time. I'm gonna kill this with you guys. Okay, this is what I'm gonna write down, guys. Okay. So let's say that there's a car odometer, okay? If you go to watch the video tonight, this will be a very similar problem. There's a car odometer, and it reads at, oh, let's say, that it reads at, I'm going to keep it real simple. I'm going to change my pen. Let's say this, do you know what a car odometer is? Odometer tells you the how many miles your car has traveled. So this car odometer reads at 5,400 miles. And you want to know, after 29 days, how far will this car, so after 29 days, what will the odometer read? What will the odometer read? So go ahead and write this stuff down. Odometer, day one, odometer reads is 5,400. What will it read on day 30? I don't even have to tell you day one, to be honest. The problem, what you might even see, is just that the odometer is 5,400. Oh, and I said 30. Cross that out. I said 29 after 29 days. So this was, boy, guys, I really messed this problem up. I'm going to restart it over. I know. Mr. Gillespie, you stink sometimes. Okay, so 5,400 miles. That's what it reads currently. What will it read? Odometer read after 29 days. And I'm going to give you one fact here, that whoever is driving every day, they travel 50 miles exactly. So here's the other fact. Car travels 50 miles daily. So earlier today in the notes in class, you were learning that, hey, there's this special type of function. And the special function is called an arithmetic sequence. What does that tell you?
It means that there's a way to figure it out.
Yeah, it means, hey, the arithmetic sequence, what it really says, what's arithmetic make you think? Math, and what type of math? Arithmetic. Addition, subtraction, real basic stuff, right? Well, this is saying, hey, an arithmetic sequence, there's always the same difference within the sequence. So, hey, if I had 1, 2, 3, 4, what's the difference between 2 and 1?
1.
Yeah, so 2 minus 1 equals 1. What's the difference between 3 and 2? 1. What's the difference between 4 and 3?
1.
Can you tell me what the sixth term would be?
5.
1, 2, 3, 4.
6.
It would be 6 because there's a difference of 1 every time, right? Okay. Well, in order to have an arithmetic sequence, you have one other fact. And that fact is your x values are natural numbers. So my x values, if they're natural numbers, where do the natural numbers begin at?
1.
Yeah, they start at 1. Is 0 a natural number? No. But 1 is. 1's our first natural number. So all the domains are natural numbers. So you have 1. What's the next one going to be? 2. Then 3. Cool. So then along the line, somewhere I'm going to come across the value of what 29 days later is. Well, if the first day is 5,400, if the first day is day 1, what day is 29 days later? 30, absolutely. So we're looking for the 30th day, not the 29th day, the 30th day. And if you have an arithmetic sequence, again, remember what I told you, there's a common difference in the y values. Your y value always has a common difference. What was the common difference before? It was 1. Well, we know what this value is. What is it? 5,400 for day 1, right? And how many miles does the car always travel?
50.
So this next day is going to automatically be, we can do the math here pretty easy. What would it be? 5,450. Cool. Well, you could go along and keep doing this for every day for 30 trials, and you could finally come to that number, but to save time, you can use a specific formula. And that, well, before we even do that formula, I need to know this is an arithmetic sequence. What tells me that this is an arithmetic sequence again? The y values have what? A common difference. And what's the common difference for the car? It does what every day? It goes 50 miles. So 5,450 minus 5,400 is what? It's 50. So my common difference is always going to be 50. Okay. Well, now I know some facts. I know that because the common difference is 50. Well, I also know now that I'm going to call D equals 50. Okay, that's my common difference. Well, n's generic. N can be any number, but n in our formula is going to be the value I'm trying to find.
30.
I'm looking for 30 because I'm looking for the domain. I'm plugging the domain's value in here, right? Good job. So 30. I'm looking for n. Cool. So this is what my formula is. The formula is it's a sub n equals the value of a sub 1. What's the value of a sub 1? Here's 1. So what's a sub 1? 5,400. Okay. Plus n minus 1 times d. So what I want you to do is take all of these values and plug it in. And tell me what you get for an answer. Don't yell it out right away. D is the common difference. I'm going to wait for Ian, and I'm going to start showing you guys how to solve it on here, just in case there was a mistake. So we got 5,400 plus, well, 30 minus 1 times 50. What did you guys get? 6,850 is it. Hey guys, that's basically what you learned today in class. I just want to make sure that we're clear on it. Again, go to the video tonight just to get some more clarity. Okay, yeah. But study those tests. I'm giving you guys some problems that are similar to the test because y'all came into work. Okay?
Okay.
Good job, guys. Have a good one.